bitches? I'm back again, proceeding to give you what you need in this bitch. Back with Bubblesort once, a Codewars exercise done, or it will be done, in the Python programming language. Yeah, back with another exercise, folks. And I like this one. This is pretty interesting. It's taking a piece of the classic Bubblesort algorithm. And if you don't know what Bubblesort is, of course you can look it up via the link that is right here from Wikipedia. Once you find this exercise in your own Codewars login, but whatever. I gotta proceed. So the description says Bubblesort's an inefficient algorithm that's simple to understand and therefore often taught in intro computer science courses as an example of how not to sort a list. Nevertheless, it's correct in the sense that it will eventually produce a sorted version, blah, 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 blah. Yeah, whatever. So let's kind of cut to the chase here and go down here and say at the heart of Bubblesort is what's known as a pass. Let's look at an example of how a pass works. All right, you look at this list right here, and the objective of Bubblesort, of course, is to sort the list. And what's explained down here is that you initiate a pass by comparing the first two elements, finding the greatest, and if the greatest is first, you swap them. And then you compare the next two. Really, it's a continuous process of comparing two elements to each other. So you compare these first two, and if 9 is greater than 7, they get swapped. So it's 7, 9. And then what you do is you end up comparing the next two, which, because the 7 has been swapped, it's really 9 and 5. 9 is the greater, so 9 moves over to here, and then 5 is here. So after that one, those first two, I guess, interactions, it's 7, 5, 9 instead of 9, 7, 5. And really what's going to happen is that because 9 is the greatest, it's going to end up being placed all the way at the end. And that's going to be one pass through this algorithm. And it shows you down here that this piece is after one swap, like I was showing you up there. Down here is after all the comparisons have been done. Because really what you do, and I know I'm kind of explaining this in a not really a linear way completely, but hopefully you'll get it. A pass is really comparing each adjacent set of elements to each other going to the right. So we compare, well, starting out here, compare 9 and 7, then the next two, then the next two, then the next two. A pass is doing all of those adjacent comparisons all the way to the end. That is what a pass is, and that is the objective of this exercise. It is to do one pass through the list until you get to the end. Once we get to the end, one pass is complete. The real Bubblesort does more than one pass, of course. It really does all the it passes until the list is completely sorted, basically. So it doesn't just do one, it keeps going again until the list is again and again until the list is sorted. But in this exercise, all we got to do is one pass, and down here at the bottom is the result of that one pass, where, as I was saying, the 9 to start out, this 9 is the largest. So as you compare the 9 to every single one, it's going to end up at the end. That is like one pass, the 9's at the end, and the real Bubblesort would go ahead and, I believe, go back to the beginning and do 2 by 2 comparisons again to the end. and then again, and then again, again and again, it would do it. So I'll say it again. The objective here is to do one pass through the list. And so we see down here with the task, given an array, your function should return a new array equivalent to performing exactly one complete pass on the original array. Your function should be pure. It should not mutate the input array. Mutate means change, so it should not take the original array. Really, it's a list. We're going to be using a list, so it should not take the original list and change that list. I don't know why it has this requirement here. It's kind of silly in my opinion, but it just adds an extra layer to your coding. So get over it. It is what it is. Now we can get into the code, my friends, my coding ninjas, or my bitches, as I said earlier. I don't know why I said that, but here we go. Let's get into this code. So L here is going to be a list that I'm going to take one pass through, not this kind of pass. Yiggity yo yo yo. Okay, so it says in that task there that we cannot mutate, we cannot change the original list. So I cannot take L and do my pass on that for some odd reason. This individual decided to have it that way. So my way around this is to simply copy the elements from L to a new list. So I'm going to create a new list here, and I'm going to make it equal to a full slice of L. That's an interesting phraseology, right? A slice of L. Well, what I'm doing here, I'm using the slice mechanism to get a copy of the entire list. Because when you slice like this, it means from the left side of the list all the way to the end, the right side, get everything. This is a convenient way to create a copy of a list, if you don't know. And this is my way around it. Maybe there's some more best practice computer science-y way to do it, but this is how I'm going to do it here for this little exercise. Overall, my algorithm here to do a pass through this list is going to be to loop from the beginning to the end of the list and compare each adjacent set of elements, and if they are not in ascending order, I'm going to swap them. That's what I'm going to do. So I'm going to loop through. Actually, yeah, it's a copy, so it's got elements in it. So this is the setup for the loop. I'm going to start at the beginning of the list and then loop until I am on the second to last element. I'm doing this because I'm comparing adjacent elements, so I'm going to be looking ahead to the next element for each iteration here. Because I'm looking ahead, I need to stop at one less than the end so that I can look ahead, so that I can index ahead. Because if I'm on the last element, I am not able to index ahead, as I'm sure some of you know. So here I'm going to do I'm going to compare the current element to the next element, index I to index I plus 1, and I don't need parentheses here, so I'm not going to use them. So say if not ascending, swap. Whoops. Because if the number on the left side is greater than the number on the right side, these two numbers are in descending order. I want to make them in ascending order, so I'm going to swap them. And I'm going to use the classic swapping algorithm that I actually first saw in the book, The C Programming Language, from back in the day. That's actually how I first learned about it. You may have seen it there too. Great book, by the way. If you want to learn C or look at like a classic programming book, pick up The C Programming Language by Brian Kernighan and I believe Dennis Ritchie, I think. I know one of those two guys, authors of it. I'm sure Kernighan does. I'm not sure Ritchie. It may be another guy. But anyway, great book from the creators of the C language. How cool is that? Like the guys who created the language wrote a book about it. I'm sure it's been done many times before. But anyway, not as well as they did. Okay, so I'm gonna do the swapping algorithm back to the context here. So to do this classic swapping algorithm, of course you're going to swap two things, and I'm realizing I can totally do this in a Python way, but you take one thing, put it in a temporary variable, make the two things equal to each other, and then take that value from the temp variable and put it in the other one. That's a very quick explanation, but hopefully you can follow this in code here. I'm going to put the element on the right into a temp variable, and then I'm going to... My typing is all messed up today. I'm going to take that element on the right and store the element on the left in it. Then I'm going to make the element on the left equal to the temp, which this effectively swaps the two. And this right here is going to handle one swap, and it's going to continually go to the right, comparing every two elements and swapping them if necessary. If they are not in ascending order, it's going to swap them to make them in ascending order. And there really isn't much more there. Return bubbed, like my variable naming there. But yeah, that is it for this one, because it's going to go through, do the swaps. It's only doing one pass, and that is one pass of the Bubblesort algorithm. And so, let's test it out. Thought there had to be an error. No error. Correctamundo. Yeah. And I'm realizing there's a totally Pythonic way to do this. And I think I'm gonna try it out here real quick, just from memory here. Because yeah, you can swap like this, but Python has a built-in swapping mechanism. I'm gonna try it here. Live TV, folks. Let's do it. I believe it's like this, where it's going to be something like this, where it's like, get this all matched up here. There should be a swap where Python has this facility or this syntax where if you list two variables or elements in a certain order and then you swap the order, you swap the values in those things. So it effectively does a swap. The same code that I had here before can be replaced by this, I think, if it works, where I plus 1 is going to go in I, and I is going to go in I plus 1. Just going to swap the values using this syntax. So let's check this one out. I think it's going to work. I'm feeling it. And it works. There we go. Yeah, so this is another way to do it. You saw the other way. If you didn't catch it, rewind, but this is, as I said, a more Pythonic way. So we'll go with this one. I'm gonna stay with this. So here we are, folks. Bubblesort once. I think that's the name of it. If it isn't, whatever. Another Codewars exercise. Go check it out. Go do it. Do your own version. But for me, that's it. And I'm out.